So, good afternoon everyone. Today I am going to discuss about the computer and network subject unit 4. In previous video we have discussed the introduction of unit 4, that is transport layer services, up to addressing Berkeley sockets. In that Berkeley sockets we are having some addressing addressing connection establishment, connection release and error control, flow control, multiplexing. Now, I am going to continue connection establishment. Okay. So, what is mean by connection establishment? With the packet lifetime, bounded, it is possible to devise a foolproof way to establish connection safely. Packets lifetime can be bounded to no maximum use when the following techniques. So, restricted subnet design, putting a hop counter in each packet, time stamping in each packet, and by using the three-way handshake a connection can be established. This establishment protocol does not require both slides on to being sending with the same sequence numbers. So, what is mean these all things? So, connection established means nothing but whenever the two devices are having, two devices means just assume that you having the computer 1 and computer 2, like you can think it is a client or server. So, between the client and server I am going to establish the connection. So, how I will really establish the connection? I am sending the request. Both devices does not have any relationship with each other. So, in order to get the relationship with them, so I am providing the connection request to the another device. So, one device to for another device. So, device 1 is sending the connection request to the device 2 through the TPDU, transport protocol data unit. So, source just think that I having the source and destination. Okay. Source and destination, source is sending need to establish the connection with the destination. So, in order to establish that I am sending the connection request message to the destination by with the help of TPDU. TPDU means transport protocol data unit. It carries the message, whatever message I am sending, that CR message that sends to the destination. So, after receiving the request to the destination, it accepted the destination request. Okay, whatever the request came from the source, the destination will be accepted and it gives the reply. Okay. At normal setup procedure, when host 1 initiates, the host 1 chooses a sequence number x and sends a connection request through TPDU to host 2. So, the host 2 will be replies, he accepted the connection request and he replies with an acknowledgement TPDU acknowledging x and announcing its own initial sequence number, that is y. Finally, the host 1 acknowledges and host 2 choice of an initial sequence number in the first data TPDU that it sends. So, this is the explanation of this connection establishment. If you see the diagram, you neatly understand how the connection will be established between the host 1 and host 2. So, you think that this is the host 1 is the source and host 2 is the destination. So, host 1 source will be sent at the connection request. Connection request means CR request I am sending. So, this CR request what here is doing, this CR request is reached at the host 2, that is destination. Destination received that connection request and he accepted. After accepting, he sent the reply to the host 1 that I am accepting your connection. So, that is why I am sending the acknowledgement of x with his along with his sequence number, that is y. Okay. After receiving the reply by host 1, it sended the data along with his sequence number x and acknowledgement y. Acknowledgement y he is sending, your reply is received to me. So, he is acknowledging to host 2. So, this like the communication will be occurred between the two devices like source and destination. Okay. So, next whenever the connection is communication is occurring, if we get any problem like network can loss, storage problems or any duplicate packets will be occur, I am using some problem in order to solve that problem. Tomlinson introduced the three-way handshake. Okay. So, what is mean by three-way handshake? So, three-way handshake he is introduced. So, let us see how the three-way handshake works in the presence of delayed duplicate control segments. So, delayed duplicate control segments segments is what ma? So, whenever I am sending the connection, okay, I am sending the connection. So, already I have the connection between the two devices. Whenever I am send the another connection, become the duplicate control segment. Okay. So, the first segment is delayed duplicate connection request from an old connection. So, the segment arrives at to the whatever the segment I am sending, that is arrived to the host 2 without host 1's knowledge. Host 1 without acceptance of the host 1, the request is reached to the host 2. Okay. So, the host 2 reacts to this segment by sending the host 1, an acknowledgement segment is effect asking for verification that host 1 was in need trying to set up a new connection. So, when the host 1 rejects the host 2's attempt to establish a connection, so host 2 realize that it is tricked by deployed duplicate and abandons the connection. Okay. So, if you see the diagram, you can understand very easily. So, this is the host 1 and host 2. So, already I am having the connection between the host 1 and host 2, that is CR request. So, whenever the segment is deploys, I mean, see, if you see this point. So, the first segment is deployed duplicate connection request. So, he is sending the another request as a connection. So, already he is there connection, the connection is there. So, that CR connection is reached without the reference of the host 1, the duplicate connection request is reached to the host 2. Host 2 is thinking that host 1 is send a request to me. Okay. See, that is why he is sending the acknowledgement along with his sequence number to host 1. So, host 1 is rejecting that, I am not sended any connection to you, that is that host 2 thinks that it is a duplicate one. Okay. So, this like the communication will be occur. Okay. So, this is the delayed duplicate does not damage, but any loss of data will be not occurred. Okay. So, this is one way of connection. So, next one is connection release. What is mean by connection release? So, connection release means what? So, it is easier than the connection establishment. So, in the connection establishment, we have to send the connection request and acknowledgements after data. This like we have to have communication between the connection establishment. A connection release is very easy, and releasing a connection is easier than establishing. So, there are two styles of terminating a connection, that is asymmetric release and symmetric release. So, what is mean by asymmetric release? So, asymmetric release is nothing but it is a telephone system works when one party hangs up, the connection is broken. Symmetric release treats the connection as two separate unidirectional connections are required each one to be released separately. Okay. So, for this connection release, we are having two types in order to release the connection. One is asymmetric and symmetric. So, I am having the diagram, you can see the diagram, you can understand very easily. So, this is the diagram we are having, here having host 1 and host 2. So, here host 2, this is called, this diagram is asymmetric release may result in data loss. This is the one example diagram. So, regarding the asymmetric release, here I am having the host 1 and host 2. Okay. In the host 1, I am sending a connection request to host 2. Okay. I am sending the connection request to host 2. After receiving the connection by host 2, he accepted the connection request and he sent the acknowledgement to host 1. Okay. So, perfect communication is occurring. So, first host 1 is sending the connection request, host 2 is accepted that request and he sent the acknowledgement to host 1. Again host 1 what he did? He sent the data to the host 2. Okay. So, host 2 is sent data. After receiving the data, suddenly host 2 send the disconnect request to host 1. So, at that time the data is simultaneously occurring, is moving from host 1 to host 2. So, first data he sent it, again he is sending the data, second data is sending disconnect request is reached to the host 1. So, whatever the data he sent second time, that is lost. Okay. That the data will be that no data are delivered at the host 2 and data will be lost. Okay. So, this is a asymmetric, anyone is disconnected, other will be stopped, other connection will be disconnected. So, here I am having the explanation. After the connection is established, host 1 sends a TPDU that arrives properly at the host 2 and host 1 sends another TPDU. Unfortunately, host 2 issues the disconnect before second TPDU arrives, the result is that connection is released and data are lost. So, this is the working of this asymmetric release. Next, coming to the symmetric. So, symmetric release is nothing but in which each direction is released independently of the other one. So, here a host can continue to receive data even after it has a send disconnect TPDU in the following diagram. So, if you see this diagram, in this diagram I am having host 1 and host 2, I am having this sender DR means disconnect request. So, after communication is completed, I am going to disconnect the communication in the symmetric form. Symmetric form is both are independently disconnect their connection, then only the two devices will be disconnected. Okay. So, sender host 1 sending the disconnect request to the host 2. Okay. So, by using this start timer, with the start timer he sended the host 2 and host 2 accepted that, and he also sended the disconnect request. The connection is released connection, I am releasing the connection. Again send acknowledgement, same acknowledgements sended to the host 2 that I am also releasing the connection. So, this like the communication, two sides they have to release the connection, then only complete disconnection will be occurred in this asymmetric. So, these are the two types of releasing connections we are having, symmetric and asymmetric. Okay. So, next coming to error control and flow control. What is mean error control and flow control? So, error control is ensuring that the data is delivered with the desired level of reliability without any errors. So, error control means what? Whenever I am delivering the data from one node to the another node, I am getting so many errors. So, due to connection variations of devices and variation of signals, through that data will be losses, delayed, and some traffic overflow of traffic. These types of errors will be occurred. So, in order to overcome that problems, I am using the error control to stop that. So, without any error, level reliability of communication will be occurred. So, between the two devices, flow control is keeping fast. Flow control is why we are using whenever the transmitter is faster between the two devices, to overrunning of that we are going to slow down that at the receiver. Okay. So, in our both of these issues can be solved by the following. So, these issues can be solved by flow control and error control by error detecting code and sequencing number, automatic repeat request. So, packet carries an error detecting code. So, error detecting code means what? Whenever the data, whatever the information we are having, that is correctly received at the destination or not. In order to know that, we are using the error detecting code. In that, we are using the CRC, cyclic redundancy check, and checksum. Okay. So, that is one point. Another is every data, whatever the data we are sending from source to destination. So, the data will be arranged in the form of packets or any messages. For that, messages or any other packets, we are providing the sequence numbers in order to identify itself, and whenever the data, whatever the data we have sent from source to destination. So, any data is lost at destination. So, in order to recognize that, we are having the sequence numbers. So, whatever the sequence numbers I have not received at the receiver side, that the same data, if it is not received at the receiver, it does not send any acknowledgement. So, the sender will be wait for until some time for the acknowledgement. If he does not receive any acknowledgement regarding this whatever the loss of data, he send the same data again by using the automatic repeat request. Okay. Automatically it will be done. Okay. Automatic repeat request. So, these are the two important points we are following this error control and flow control. So, next the maximum, there is a so in this there is a maximum number of packets that the sender will allow to be outstanding at any time, passing if the receiver is not acknowledge if the receiver is not acknowledging the packets quickly enough. So, this is called sliding window protocol, which supports bidirectional data transfer. So, by employing sufficient buffer space at source and destination, if most TPDUs are nearly the same size, it is natural to organize the buffer as a pool of identically sized buffers with one TPDU transport protocol data unit per buffer, as it following figures. So, having the diagram here. So, this is the diagram. So, in this error control and flow control, the buffer size varies for different TPDUs. So, first one is chained size fixed size buffer, second one is change variable size buffer, third one is one large circular buffer per connection. Okay. So, what is mean by chained fixed size buffer? So, if most TPDUs transport protocol data units are nearly the same size. So, here in the A, if you see the diagram A, in this diagram I having the 3 boxes. So, the 3 boxes are same in size. Okay. The whatever the buffers we are using, that is in the TPDUs are same in size. The buffers are organized as a pool of identical size buffers. So, with 1 TPDUs per buffer. Okay. And next one is chained variable sized buffer. Change variable size means in this approach the buffer size problem. The buffer size is problems. So, if there is a wide variation in TDP size is difference, variations will be occur. One is small, some large and again large. Okay. So, variations in TPU sizes from a few characters typed at the terminal to thousands of characters from a file transfer, some problem may occur. So, if the better size is chosen equal to the largest possible TPDU, and space will be wasted whenever a short TPDU arrives. If buffer size is chosen less than maximum TPDU size, multiple buffers will be needed for long TPDUs. Okay. So, this is called the chained variable size buffers. Third one is one large circular buffer per connection. So, a single large circular buffer per connection is dedicated when all the connections are heavily loaded. So, in this we are having 3 steps, that is source buffering is used for low bandwidth bursty traffic, destination buffering is used for high bandwidth smooth traffic, dynamic buffering is used if the traffic pattern changes randomly. Okay. And these are the 3 things occurred in the one large circular buffer per connection. Okay. So, these are the 3 types we are having in the error control and flow control. Next one coming to multiplexing. So, multiplexing is a process of sharing several conversations over connections in transport layer. The need for multiplexing can arises in a number of ways. Okay. So, in this network we use the virtual circuits within the subnet. Each open connection consumes some table space in the routers for the entire duration of connection. If buffers are dedicated to virtual circuits in each router as well, a user who left the terminal logged into a remote machine, there is need to multiplexing. So, there are 2 kinds of multiplexings are there. So, for example, if only one network address is available on a host, all transport connections on the machine have to be used. When a segment comes in, some way is needed to tell which process to give it to, the situation called multiplexing. So, in this diagram 4 distinct transport connections all uses the same network connection, that is IP address to remote the host. Okay. So, that 2 are upward and downward multiplexing. So, this is the diagram, we can say multiplexing and inverse multiplexing. So, upward multiplexing is nothing but in the below figure, whatever the diagram we are seeing here, in all the 4 distinct transport connections uses here 1, 2, 3, 4 distinct connections uses the same network connection to the remote host. Okay. So, when connect time forms the major component of the carrier's bill, it is up to the transport layer to group port connections according to their destination and map each group onto minimum number of ports connections. Okay. So, this is called the upward multiplexing. Next, inverse multiplexing, we can also say downward multiplexing. If too many transport connections are mapped onto one network connection, the performance will be poor. If too few transport connections are mapped onto one network connection, then service will be expensive. Okay. The possible solutions is to have the transport layer open multiple connections and distribute the traffic among them and round robin basis as indicated in the below figure. With k networks connection open, the effective bandwidth is increased by the factor of k. Okay. So, this is called multiplexing. Okay. Next coming to crash recovery. So, what is mean by crash recovery? So, if hosts and routers are subjects to crashes, recovery from these crashes become an issue. If the transport entity is entirely within the host, recovery from the network and the router crashes is straightforwarded. The transport entity accept lost segments and do retransmissions. More troublesome problem arises during the crashes. Okay. So, for example, let us assume that one host, the client is sending a long file to the another host, the file server using a simple stop and wait protocol. So, the transport layer on the server just passes the incoming segments to the transport user one by one. Partway through the transmission, the server crashes. When it comes back, tables are reinitialized, so it no longer knows preciously where it was. In an attempt to recover its previous status, the server might send a broadcast segment to all other hosts announcing that it has just crashed and requesting that its clients inform it to the status of the of all open connections. So, each client can be in one of the two states, one segment outstanding S1 or no segment outstanding S0. Based on only this state information, the client must decided to retransmit the most recent segments. Okay. This is called recrash. So, for this the server can be programmed in one of two ways acknowledged, first or write first. The client can be programmed in one of four ways. Always retransmit the lost segment, never retransmitted the lost segment, retransmit only in state S0 or retransmit only in state S1. So, we having three events are possible at the server, that is sending an acknowledgement A, writing to the output process W and crashing C. Okay. So, these are the three things we are having. So, there are three events occur in the 6 different orderings, that is AC. W, AC means what? A means sending an acknowledgement, okay, acknowledgement W, AWC. So, what is AWC here? So, AWC means sending an acknowledgement, writing an AC means getting acknowledgement and crashing, okay, and crashing. W is nothing but output processor, okay. AWC means what? Sending an acknowledgement, output process occurring, writing and crashing, both are done. C of AW, it is what? C means what? Crashing. So, AW means acknowledgement and another is output process, okay, output process, okay, and WAC and WCA, these are the different events occurred, different orderings or events occurred in this, okay. So, where the parentheses are used to indicate that neither A nor W can follow C once it is crashed, okay. So, this is the diagram having. In this diagram, all 8 combinations of client and server strategies and valid event sequence for each one. So, this is the strategies by sending the host, always retransmit, never retransmit, retransmit in S0, retransmit in S1. So, AC means I already know that crashes, A means acknowledgement, W means output process, okay. Okay. So, AC lost here and again okay, lost this slide, okay. So, never retransmit in S1. So, recording these rules we are following this table. Okay means protocol function correctly, this protocol function is correctly having. So, never retransmit means protocol generates a duplicate message here. So, when never retransmit means duplication message will be occurred. Lost means protocol protocol loses a message, lost means protocol loses a message. So, here never retransmit. So, always retransmit means function protocol function correctly, okay. Okay means Lost means protocol loses a message. Whenever never retransmitted, message is lost. Okay. So, this like duplication means duplication message will be occurred. Okay, means so these are the different strategies used by receiving the host. Okay. First acknowledgement, then write, first write, then acknowledgement. Okay. So, these are the different things happening in this. Okay. So, what is conjunction control? If the transport entities on many machines send too many packets into the network too quickly, the network will become congested with performance regarded as packets or delayed and lost. Controlling congestion is the combined responsibility of the network and the transport layers. Congestion occurs at routers, so it is detected at the network layer. However, the congestion is ultimately caused by traffic sent into the network by the transport layer. The only effective way to control the congestion is for the transport protocol to send packets into the network more slowly. The main content to be discussed include desirable bandwidth allocation, regulating the sending rate, wireless issues. Okay, wireless issues. So, desirable bandwidth allocation means we can avoid the congestion by providing a good bandwidth allocation to the transport entities that are using the network. A good allocation will deliver good performance because it uses all the available bandwidth, but avoids the congestion. Good put rate of useful packets arriving at the receiver can be desired rate of useful packets arriving at receiver as a function of the offered load. As the load increases, good put initially increases at the same rate, but as the load approaches the capacity, good put rises more gradually. Burst of traffic can occasionally mount up and cause some losses at buffer inside the network. The network can enter congestion collapse. Okay, this is called the desirable bandwidth allocation. So, this is the diagram offload load and offered load. Okay, this is packets per second. So, good put delay. So, whenever the good put is there, packets per second capacity. So, desired response and conjunction collapse. Okay, collapses here. This is the good response and this is the delaying function and the offered load. Okay, AB. Next, to identify the capacity of network, the metric used is power. Power is equal to load per delay. Power will be initially rises with offered load as a delay remains small and roughly constant, but will reach a maximum and fall as delay grows rapidly. The load with the highest power represents an efficient load for the transport entity to place on the network. Okay. So, regulating the sending rate. How do we regulate the sending rates to obtain a desirable bandwidth allocation? The sending rate may be limited by two factors. The first one is flow control in case that there is a insufficient buffering at the receiver. The second is congestion. In this case, that there is insufficient capacity in the network. Okay. So, we see the thick pipe leading to a small capacity receiver. This is a flow control limited situation. As long as the sender does not send more water than the bucket can contain, no water will be lost. So, the limiting factor is not the bucket capacity, but the internal carrying capacity of the network. If too much water comes in too fast, it will back up and some will be lost. Okay. So, this is the diagram. So, this is the if the bucket small capacity receive diagram a fast network feeding a low capacity receiver. So, fast transmission rate adjustment is fast, very fast, but limited small capacity is received, and here if you see the slow network feeding in a high capacity receiver. Okay. Water is very fast. Okay. Internal conjunction large capacity is received. Okay. So, next coming to these cases may appear similar to sender as retransmitting too fast causes packets to be lost. However, they have different causes and call for different solutions. One solution of transport layer is a flow control solution with a variable sized window. sliding window protocol. The other solution is the regulating the sending rate depends on the form of feedback returned by the network. And explicit conjunction protocol, routers tell that source the rate at which they may send. Designs in the literature such as explicit conjunction protocol operate in this manner. Okay. So, ENC means explicit conjunction notification. In this design, routers set bits on packets that experience conjunction to warn the senders to slow down. Delay based feedback method, TCP measures the round trip delay and uses the metric as a signal to avoid conjunction. Packet loss based feedback method, and TCP will drop tail or read routers. Packet loss is inferred and used to signal that the network has become congested. So, wireless issues we are having, the main issue is that the packet loss is often used as a conjunction signal, including by TCP, as we have just discussed. Wireless network loss packets all the time due to the transmission errors. So, a path with a wide network, a wide and wireless link for which the masking strategy is used. There are two aspects of note. First, the sender does not necessarily know that the packet path includes a wireless link, since all it sees is wide link to which it is attached. Internet paths are heterogeneous and there is no general method for sender to tell what kind of links comprises the path. This complicates the conjunction control problem, as there is no easy way to use one protocol for wireless links and another protocol for wide links. Okay, this is called wireless issue. So, this is the diagram. Here I am having the sender and receiver. At one side a sender I am having the wide link and other side I am having the wireless link. The link layer retransmission, loss of retransmission error. So, transport with end to end conjunction protocol, loss is equal to conjunction. So, here whatever the connection I am using, here is wide link, here is wireless link. Okay. So, sender and the receiver. The second aspect of puzzle, the figure shows the two mechanisms that driven by loss, link layer frame retransmission and transport layer conjunction control. The puzzle is how these two mechanisms can coexist without getting confused. The solution must allow wireless links to detect frame losses and retransmit frames, to repair transmission errors long before packet loss is inferred by the transport entity. So, okay. So, up to here we discussed about the transport wireless issues, and in the next class we will discuss the internet transport protocol UDP, okay, and remote protocol UDP, and these are the different steps in the UDP and real time transport protocol, and these are things will be explained in the next class. Thank you.